Okay, in the last tutorial, I had explained you how an relay works, and then the problem which I had given to you was you have you need to have two switches. If you switch on one switch, the LED should come on, and then when you, this is the push button. So even if you leave it, it should continue to remain, it should continue to glow and remain on. And then to switch it off, you require another push. Okay, you will find these kind of switches are there in many starter motors and all, where you push and then it starts, and then you push the stop button, it will come to a stop. So we needed once you push and you remove, the signal going to energize the coil would be removed, right? But still it should somehow latch. So that was the problem statement. So if you see what is the circuit and how we achieve that is, this is the positive supply, 5 volt. This I explained you last time. There is a 9 volt supply. We are using a regulator to step down it to plus minus 5 volt. Okay, so we are taking this plus 5 to the switch. Once you press the switch, the output will be available here. That we are giving it to the energizing coil, right? And also, if you see, this is the contact which is there. Okay, normally this, so we are going to give plus voltage into this contact also. There, this is the output contact which will be this supply will be available here once the relay is energized. So you can see here this shifting of the relay which is happening. That when you do simulation, probably here you will not be able to visualize in this small window, but once you do the simulation, you will be able to see. Okay, so this is the supply voltage. On pressing the switch, the supply will be available here. Okay, now once it is available here, okay, even if I remove this press button, okay, still this relay should get locked. So what I can do is I can take this supply here. Okay, so this supply is available here. There is a resistance I have put out here. Okay, and through that resistance I have again made a loop and given it to the input side of the relay. Okay, so what happens is once I press it, okay, this supply will be available here. Through this resistance again it will be available here. Now even if this supply, if the switch is switched off, the supply will be available from here through this contact, through this resistance it will be available, and the coil will continue to remain energized. Okay, and the same output voltage it is available here through a resistance. I am driving an LED. Okay, so the negative of the LED is given grounded here. So even if I leave it, okay, this will continue to remain on. Okay, because of this is known as self-locking. Okay, where the output is taken and it is given to the coil itself. So once you remove also, then also this voltage will be available here. So this relay kind of gets latched. Okay, that is known as latching of a relay or self-latching relay. Okay, now how to break the latch? Okay, now to break this latch, this voltage which is available out here, that needs to be cut off momentarily. So I have put a resistance out here, and I have used the stop relay here, and I have put an ground connection. So once I press this particular switch, the voltage would there is a ground available here. So whatever is the voltage available across, so the current would flow into this resistance, and this will become ground here momentarily. The moment I close here, the ground will be available here, and this relay will get deactivated. Once it gets deactivated, this supply won't be available. So even if I leave this, then there is no that signal available for latch will not be available. So this is known as an latching relay. So I can do the simulation and show you. See, if I press this, this has got switched on. Now I have left it, okay, but still it continues to be on. Now to switch it off, I need to press the other switch, off switch. Okay, I press this, it will switch on. I press this, it will get switched off. Okay, so what I have used is, I have used a resistance, and then I have given out here into this loop. Okay, what
Can we use the first switch to switch off?
This to switch off?
Sir,
No, it's
yes,
not
sir.
possible now. In this
Okay, sir.
particular configuration, this can be used to switch on, and this has to be used to switch off.
Got it, sir.
Okay, I have used this resistance out here. Okay, and what we can also do is, You can just if no, I'm not sure if you might have a switch where if you press it will open, and if you leave it, it should be closed. So if you have a normally close switch, instead of this resistance you can have a normally closed switch. Okay, so that means when this is released, okay, this connection will be directly made into the loop. Okay, so that will become, so that will latch this relay, and when I press that, circuit which is available here, that path which is available from the output towards the energizing coil, that will be broken. So once it is broken, it will come out of the latch. Is it understood what I wanted to tell?
Yes, sir.
Yeah, here I have used one resistance, and I am dropping the potential here to make it 0 here. So this resistance can be avoided provided you have a switch which is normally closed switch. Okay, you can do that. So all those designs are possible. Okay, so my idea is just to give you these kind of circuits wherein so that actually when you're trying to implement things, so these kinds of functions can be implemented by small manipulation of the circuit. Okay, so that's all for today. Thanks a lot.
Thank you, sir.
Okay.